All right, so now that we know the basics about what a statistical study is, some good benefits of different sampling techniques, let's go into actually talking about how to create an experimental design. So in this section, we're going to look at some of the basics of planning a statistical study so that we can provide samples, so that we can determine individuals and variables and all those things. So in planning a statistical study, first we need to identify the individuals or objects of interest. It's pretty straightforward. Who or what are we trying to study? Specify the variables as well as the protocols for taking measurements or making observations. So not just identifying what characteristics these individuals have, but how are we going to measure it? How are we going to measure that? How are we going to observe that? Determine if you will use an entire population or a representative sample. And of course, we talked about the sampling methods in section 1.2. So we need to figure out, are we going to use everybody in that population, or are we only going to take a group from that population? In your data collection plan, address issues of ethics, subject confidentiality, and privacy. Remember, we're trying to eliminate as many non-sampling errors as possible. We don't want any non-sampling errors. We don't want any bias. So we got to make sure that we count all of our ducks in a row, or that we put all of our ducks in a row, and that we count our chickens, and that we don't count our chickens before they hatch. Okay, so let's make sure that we're addressing ethics, confidentiality, and privacy. So especially if you're working on a study for a business, a store, a college, or an institution, make sure to get consent also. Okay. Then we get to the data collection part. We actually collect the data. And then we use appropriate descriptive statistics methods and make decisions using appropriate inferential statistics methods. We're going to get to step 6 as we move forward in this course. Chapters 2, 3, and 9 talk about appropriative descriptive statistic methods, and chapters 7 through 11 talk about inferential statistics methods. So we're going to collect the data, we're going to analyze it to describe a particular aspect of the subjects, and we're going to use inferential statistics to make hypotheses or make accurate predictions about it. Finally, note any concerns you might have about your data collection methods and list any recommendations for future studies. Obviously, we're human. We're not going to have a perfect study every time. So once everything's finished and once we finished our study, now is the time to make an accurate reflection. Did I do everything that I needed to do? Were there any non-sampling errors that I made? Or were there any sampling errors that I made to tell me that I should study a larger population in the future, right? That last step is meant for us to give an honest evaluation about our study. Were there any concerns about the methods that we used? How do we fix those issues in the future? So if we use an entire population in a study, remember we talked about the difference between a population and a sample. If we use data from the entire population, we have what's called a census. And y'all have heard the word census before in terms of the United States Census. In a census, measurements or observations from the entire population are used. This is a more general term instead of the more specific of the actual U.S. population census. If we use data from only part of the population, then we have a sample. Again, we've already talked about the difference between population and a sample. But when we talk about the fallbacks for using a population study, for example, every 10 years, the U.S. Department of Commerce Census Bureau conducts a census of the United States. The issue with that is that because you're taking a census of everybody in the United States for such a long time, these can be very expensive and difficult to obtain. Again, the United States is very, very spread out. They may use different multi-stage sampling techniques for this, but actually, no, they won't use multi-stage sampling because they're conducting population studies. But even still, point is, stuff like this can be very expensive and very difficult to obtain. Also, you have what's called overcounting. Overcounting is when you count the same person more than once. In 2000, slightly more people were counted twice than the estimated number of people missed. So, for example, if you go to college and you live in a dorm, or if you live in an apartment, you might be counted on the census based on where you live, in addition to where your parents live, because you may still stay with your parents from time to time. Okay, so that's an example of overcounting. So overcounting is a concern. Expense and difficult things to obtain. But the census is complete because it is from the population. But now we'll talk about experiments and observations. We talked about simulation when it comes to simple random sampling. Sometimes a simulation is what's called a dry lab approach. But we can also do other things like an observational study or an experiment. So when gathering data for a statistical study, we want to distinguish between the two. For example, in an observational study, observations and measurements of individuals are conducted in a way that doesn't change the response or the variable being measured. There's a famous physicist called Heisenberg, and Heisenberg has this rule called the Heisenberg uncertainty principle. And in a nutshell, what it means is knowing that an object is being observed, like the object knowing that it's being observed will change the behavior of that object, right? So in an observational study, we got to make sure that our observations and measurements are done so in such a way that we don't change the variables being measured. And then we have an experiment. In an experiment, a treatment is deliberately imposed on the individuals in order to observe a possible change in the response or variable being measured. So maybe in an experiment is a little bit more upfront than an observational study. Because remember, in an observational study, we want to make sure that we don't conduct ourselves in a way that changes the response of the variable that's being measured. In an experiment, you're looking for a change. You're deliberately imposing a treatment to bring about a change in the response or change in the variable that's being measured. So here's an example. In 1778, James Cook landed in what we now call the Hawaiian Islands. So he gave the islanders a present of several goats, and over the years, the animals multiplied into wild herds, totaling several thousand. And as far as their diet goes, they ate almost anything, including the famous silver sword plant, which was once unique to Hawaii. At one time, the silver sword grew abundantly on the island of Maui, which is in Haleakala, a national park on that island. The silver sword can still be found somewhere. But each year, there seem to be fewer and fewer plants. So biologists guessed, they made a hypothesis, that maybe these goats were partially responsible for the decline in the silver sword plants and conducted a statistical study that verified their theory. All right, so here's what they did. To test the theory, they set up stations in remote areas of Haleakala in Maui. At each station, you had 2 plots of land similar in soil conditions, climate, and plant count were selected. So one plot was fenced to keep the goats out while the other was not. At regular intervals, a plant count was made at each plot. This study involved an experiment because a treatment, aka the fence, was imposed on one plot. So this was an example of an experiment. The experiment involved 2 plots at the station. The plot that was not fenced represented the control plot. This was the plot on which a treatment was specifically not imposed, although the plot was similar to the fenced plot in every other way. So in a statistical study, okay, you have what's called a control group and you have a treatment group. Okay, the control group, like you said here, in the control group, you're applying the treatment. You're not applying the treatment for. You're not applying the treatment, but the group that you're using is similar to the other group. Okay, the treatment group was the plot that was fenced in. Okay. So when we use statistical experiments, they're commonly used to determine the effect of a treatment. Okay. However, the design of the experiment needs to control for the other possible causes of the effect. So this is where the placebo effect comes in. The placebo effect occurs when a subject receives no treatment but incorrectly believes he or she is in fact receiving treatment and responds favorably. A good example of a placebo effect is if you're conducting a study about FDA safety for a new medicine, right? So let's say the medicine comes in a pill, and you're going to have your treatment group and you have your control group. The control group would technically be the group that receives the placebo, meaning that they don't receive the actual medicine. They maybe receive like a sugar pill or something like that. But in their minds, they think they're getting the actual medicine. So the subject receives no treatment, but they believe incorrectly that they're receiving the treatment. And you're looking for that favorable response. Okay? So again, to account for the placebo effect, patients are divided into two groups. You have the treatment group and you have the control group. The treatment group receives the prescribed treatment. So in the other example with the silver sword plants, you had the fenced-in plot. That was the treatment group. The control group was the one that was not fenced in. But in the case of the medical community, the control group receives a dummy pill or a placebo pill. Okay. At the end of the treatment cycle, the condition of the patients in the treatment is compared to the condition of the patients in the control group. All right. Now, how do we assign patients to treatment and control groups? So here's a way to do it called a completely randomized experiment. It's one in which a random process is used to assign each individual to one of the treatments. You could use, assuming that you have enough people in your population, you could use a random number table to do this, or a random number generator to do this. So here's another example. For a completely randomized experiment, so let's say that for more than a decade, surgeons have been using a laser procedure to drill holes in the heart to maybe try to relieve chest pain. Many patients reported a lasting and dramatic increase in the chest pain symptoms. So is the relief due to the procedure, or is it a placebo effect? So there was a research project at Lenox Hill Hospital in New York City that provided information by using a completely randomized experiment. So the laser treatment was applied through a less invasive, like a catheter laser, process. A group of 298 volunteers with severe untreatable chest pain were randomly assigned to get the laser or not. So they were randomly put into to two groups. One of them was the treatment group, the other was the control group. And of course, these people didn't know what group was which. So the patients were sedated, but they were awake. Again, this is a less invasive procedure. They heard the doctors discussing the laser process, and each patient thought they were receiving the treatment. Okay? So here's how the experimental design was pictured. So you have patients with chest pain. They randomly assigned two groups. You have one group that's getting the laser treatment, and the second group that's not actually getting the laser treatment. And they're going to compare pain relief to those who actually got the treatment and those who didn't. So the laser patients, the treatment group actually did well. But shockingly, the placebo group showed more improvement in pain relief. So that probably tells us that maybe this process is not really the best way the best method to relieving chest pain relief. The medical impacts of the study are still being investigated. So how do we control the variables being used? When we make our random assignments, we go through the experiments, but how do we control the variables? One way to do it is through what's called blocking. A block is a group of individuals sharing common features that might affect the treatment. So one way that we can look at this is through a randomized block experiment. Individuals are first sorted into blocks, and then a random process is used to assign each individual in the block to one of the treatments. So this is kind of more like a stratified sampling kind of deal, where you're putting individuals into groups, and then you're randomizing each person in each group to one of the treatments. So an example of that is a randomized block design utilizing gender for blocks in the experiment involving laser holes would be, so let's say you're trying to separate this by gender. So in a randomized block assignment, you would take all your patients, you separate them by male and female, then you take the men, randomly assign them to group 1 or group 2. Either this one gets the laser holes, the other one doesn't get the laser holes. And then same thing for the women. They put them into the 2 groups. Okay. Here's what a good experimental design looks like. So first, it has a control group. And again, a control group is the group that receives the dummy treatment, enabling the researchers to control for the placebo effect. Does the placebo effect have a big impact on the actual thing that you're trying to study? Right? A control group is used to account for the influence of other known or unknown variables that might be an underlying cause of a change in response in the experimental group. These are what's known as lurking or confounding variables. So lurking variables are these known or unknown variables that could be a cause of a change in response in the experimental group. Then you also have randomization. Randomization is used to assign individuals to the 2 treatment groups. When you do randomization, it helps prevent bias in selecting members for each group. And the third good characteristic is replication. The replication of the experiment on many patients reduces the possibility that the differences in pain relief for the 2 groups occurred by chance alone. The more you repeat a process, the more accurate your data is going to be, so that you know for sure that this isn't a coincidence, it's not chance. Then we get into surveys. Before we get into surveys, another good example of an experimental design is what's called a double-blind study. In a double-blind study, it means that neither the individuals in the study nor the observers know which subjects are receiving the placebo or the actual treatment. This really helps control for subtle biases that a doctor might pass on to a patient. So again, in a double-blind study, both the observers and the patients are blind to what's going on. Obviously they know that they're studying something, but they don't know which group is which. They don't know that which group is which. But when we talk about surveys, so whether you've decided on using a sampling, using a census, observations, or experiments, a common means to gather data about people is to ask questions. That's what a survey is. A survey is a common means to gather data by asking questions. Now, here's the thing about surveys. Okay, we talked about surveys a little bit when we talked about when we went through convenience sampling. Oftentimes, surveys may not be the best method to go about collecting data. First off, individuals can either be unable to be contacted, or they could just outright refuse to participate. Okay, so you could get a non-responsive individuals. The more non-responsiveness that we have in a population, the more undercoverage you're going to have. And again, ideally, we want our sample frame to be the population. But if we have non-responsiveness from our population, then we're going to have more undercoverage. Also, the truthfulness of your response. The respondents may lie intentionally. They may reluctantly say yes to doing the survey, but because of their predispositions to the study, they may not want to be completely honest and completely truthful. Also, people, if they do try to answer the questions truthfully, there's a good chance that they may not accurately remember event, people, places, or things that occur. Also, hidden bias. So we got to try. Remember, we're trying to eliminate as much bias as possible. That doesn't mean we're going to completely eliminate it. So the order of the questions that are being asked may lead to biased responses. Also, if you're doing something called a Likert scale, like that means that your responses are either unlikely, somewhat likely, neither likely nor unlikely, likely or very likely, those kind of things. Those may force responses that don't quite reflect the respondent's feelings or experiences. So the choices that you choose from in a survey may not reflect what you're feeling about the situation. Also, the wording. Okay, wording can be very tricky. Things like often, seldom, and occasionally mean different things to different people. I might say that, hey, sometimes I read books when I'm at home, but I may have only read one book in the last 6 months, as opposed to someone that says, oh, sometimes I read books when I'm at home, and they end up reading like 5 books a week at home. So the wording in a survey can be vague and can mean different things to different people. Also, the interviewer themselves, the tone of their voice, the body language, dress, gender, authority might influence responses, right? When I gave the example of being interviewed by WAFB, there was a little bit of interviewer influence because I knew that he was from WAFB. So that maybe kind of helped influence the responses a little bit. Also, if somebody's, tone of voice, body language, if someone can speak very, very well, then there's a little bit of more positive energy coming from that interview, right? So that might influence your responses. You may feel more inclined to answer more favorably to what they're asking. And then, of course, voluntary response. Individuals with strong feelings about a subject are more likely than others to respond. And not just respond, but respond in great fashion. And also, because they have strong feelings about a subject, sometimes they may not be as well informed, or sometimes they might have their bias clouding their judgment or clouding them being well informed of the subject. Okay. So a study with voluntary responses is interesting, but it may not be reflective of the population. Okay. Now, again, when we work on experimental studies, some of these studies can be complicated by those lurking or confounding variables. Okay. So again, an alternate definition: a lurking variable is one for which no data has been collected, but nevertheless has influence on other variables in the study. So, for example, let's say you're considering a study involving 2 variables: amount of gasoline used to commute to work and the time it takes to commute to work. So level of traffic congestion is a likely lurking variable that increases both of the study variables. So, because if you're stuck in traffic, it burns more gas and it takes up more time to commute to work. So we're not studying traffic congestion, but it still has influence on the variables that we're trying to study. 2 variables are confounded when the effects of one cannot be distinguished from the effects of the other. Confounding variables may be a part of the study, or they may be outside lurking variables. Here's another example: GPA, difficulty of courses, IQ, available study time. Some of those variables might be confounded. For instance, students with less study time might opt for easier courses. Okay, but you can't really. It's kind of, think of the word confounded like you would the word confusing. Okay, if 2 variables are confounded, we're not sure which variable's effect is making this kind of effect, right? If I'm not making good grades, does that necessarily mean that my GPA is low, or I'm not making enough time to study? Those kind of things can confuse. Or, like I said, they may be outside lurking variables. All right, so again, we talked about gasoline used to commute to work and the time it takes to commute to work, right? The lurking variable, like we said, would be traffic congestion. Variables that might be confounded when it comes to success in the classroom. Okay? That could be IQ, that could be GPA. It could also be also involve study time. We don't know. We can't distinguish which variables affect or have more effect than others. All right, so again, the 3 most common techniques for gathering data are observational studies, experiments, and surveys. Now the question we think is, when do we think is best to use each technique? So when we talk about surveys, surveys would be better used for gathering information across a wide range of many variables. So something that you can ask multiple questions, right? But remember, we have to take care to make sure that our survey is constructed in such a way that we have as less non-responsiveness and bias as much as possible. Okay, so surveys are good for gathering information across a wide variety of topics. Observational studies are most convenient for gathering information. And of course, protocols for taking measurements and recording observations. We got to make sure to specify very carefully what we're studying. When it comes to experiments, experiments are the most stringent and restrictive data gathering that is out there. It can be time-consuming and expensive and difficult to administer, like a census is. Okay? So when it comes to experiments, the goal is often to study the effects of changing one variable at a time. And because of these requirements, the number of variables may be more limited. So we have to design experiments more carefully to ensure that the resulting data is relevant to the research questions. We got to be as quick and concise as humanly possible when you're going through these studies. Okay, so if you're trying to now keep in mind whatever you think is best to use each technique, experiment may be the most stringent, but it's also the best technique for reaching valid conclusions. If you want to be 100% sure, as close to 100% sure about the effect that something has on your population or sample, an experiment's the best way to go. By carefully controlling for other variables, the effect of changing one variable in a treatment group and comparing it to a control group can give high confidence in your results. When you go to observational studies, that's the second most effective. But we just have to make sure. We also have to make sure that we're not that our observation does not affect the behavior being measured or observed. We gotta think about Heisenberg's uncertainty principle here. The least effective technique for drawing conclusions is the survey. Right? We talked about the pitfalls of the survey, and by nature, they can't really give exact results. So, like for example, a medical study utilizing a survey asking patients if they feel better after taking a specific drug gives some information, but not precise information about the drug's effects. So surveys are more about gauging attitudes and opinions about certain things, whereas if you're looking for information about the drug's effects, you need either an observational study or an experiment. Okay, but surveys are more used for convenience sampling than anything else. So we got to make sure to take care on constructing the right study for the right situation.